Hello everyone to the last talk of Unreal Fest. I promise I'm not gonna bother you with too many technical details, and I hope it will be a bit more fun maybe. My name is Dmitro, and today we're gonna talk about optimizing mobile live games. There will be a lot of learnings that we made shipping Fortnite continuously for way too many years. So briefly about me, who am I to talk about this? I'm a platform engineer specifically for mobile on Unreal team. I have 15 plus years in the gaming industry, and I really love low-level systems. Agenda for today is mostly to give an overview of what's the difference between non-live games and live games, give you some sort of hints what kind of toolings we have, give you some idea what to look for when you profile your games, and then give you some tools what to do with the results. So let's just go straight into it. What the difference? So typically for non-live games, as all we did, you roll through long production and then 3-4 weeks before release, you try to run it and you get 10 FPS and you panic. And you're like, hey, we need to do something, we need to do something. Then you crunch for 4 weeks, you make the release and you forget about it. Done. Live games make it so much worse. We ship Fortnite every 2 weeks. So this panic never stops. As soon as you're done with one release, you have the next one going. And maybe sometimes they overlap. You try to optimize 4 weeks in advance. Sometimes you fail. Sometimes you optimize 2 days before release. So the point here that I'm trying to make, this yellow line is essentially another work stream that runs in parallel with production. And please try to allocate some manpower to it. Otherwise, you will struggle shifting people around. We have, on Fortnite, we do have a lot of people allocated to it. But being another work stream means it needs tools. Like we no longer can just, hey, let me run the game on mobile phone and see how it goes. We need tools to do well in that work stream. So what kind of tools do we have? In Unreal, we ship a replay system. You can think about it as multiplayer game thing that records your gaming session and then allows you to replay it. We ship automated performance testing framework. We have extensive scalability framework, and we have various profilers. So what the replay system? Like, without going too much how it's implemented, it allows for profiling work. It allows you to record a gaming session once and then replay it in a reproducible way how many times you want. Why? So we can do A/B comparisons. So if someone optimizes something and wants to see what the actual impact is, they can do A/B and see, okay, I improved by 0.2 milliseconds. Good, ship it. It might allow you to track changes over time. Let's say over a span of multiple weeks. Are we tracking down? Are we tracking up? What's our memory usage? Is it go down or not? And some other use cases that I don't even know about. How it works? It works on top of replication system. So if you ship a multiplayer game on Unreal, it just works out of the box for you. If you have single players game, you can enable it. Shouldn't be a problem. And it's all based on demo NetDriver class. You can see how it's implemented. And for most part, it just works. You don't need to do anything to your game. The Lyra starter game that we have in FAB just comes with everything you need. So it just works. You can look inside how it's implemented. And it's used super extensively on Fortnite. We do on a level of dozen replays per day. So replay itself is a file. It's a binary file. We commit it to we suggest you to commit it to version control because it depends on code and assets of your game. And replay is gonna break. Like, just assume you change the code, replace is invalid. You change assets, replaces are invalid. It's okay to re-record replay once in a while. You might also want different replays for different modes. Maybe you have like one versus one mode in your game, or 4 versus 4, etc. So it's okay to have multiple replays. And I know a lot of our tech sometimes is just a black box. So just to give you, to make you less scared of this, all of this can be invoked by hand. So every client made with Unreal is usually bundled with everything here. So you can just pass a bunch of command line arguments and it will just work. In this case, it uses our perf test framework to run a replay. And this will capture profiling data and so on. So it's not a magic thing. It's just something we ship in the clients and you can just run it. I know on mobile specifically, a lot of people are like, how do I pass command line arguments? I just have an icon on my phone. Like, there's no way to do it. So here's some tips for you. First one is for Android. This is a way how to start Lyra with custom command line. You don't need to memorize it. It's just something that, what I want you to take away here, this exists. So next time you need this, just look it up. Second one, we ship a command line tool to push and pull files from iOS device. So unfortunately on iOS you need to push a text file and that's your command line. Okay, so what the alternatives? What if you can't use our replication system in any way? You can use take sequencer. Maybe you just record the take. It's like in-game movie essentially and use that as your replay. You can use input replays. It requires you to be a bit more strict about your game logic because it's difficult to make it deterministic out of the box. But if you can, do it. Or depends on your game genre, just roll your own. And it can be, maybe you have a very special game and needs like special solutions. Okay, so now we have replays. What do we do with them? We have automated performance testing framework. It can run replays for you. It can also have static camera scenes. Tech artists love static camera scenes for performance. It also integrates with build graph, so it can run on Hort. You can just ask Hort, hey, run replays for me on mobile phones. Good. And it collects profiling data for you. On Fortnite, we primarily do CSV on LLM traces, but it can also collect insights for more deeper investigations. And it can generate interactive reports. I don't think many people have seen it, but this is what we use daily internally. Essentially, you get perforce CL, you look, okay, what's the report for that CL, and then do something about it. So how does it look? We ship the tool to convert CSV to interactive reports called perf report tool. In Unreal fashion, everything is in source code somewhere hidden in the repository that you need to find. I'm sorry about that. But just to give you a glimpse, so the important part on the bottom is frame count. And what you might not be used to, at least in mobile profilers, this is 20-minute recording of Fortnite running on Android phone. And these are actual Fortnite times. So internally, we can just look and, hey, during replay something happened, and let's go investigate. And we can compare it run to run over like a span of weeks. You have this to your disposal. So when you think about making optimization work streams in your companies or studios, this is a tool that you have, you can just use. You don't have to use it, but it's a very convenient thing to get an overview of what's going on. Okay, now the fun part. What can you expect when you profile? The very a very big difference between mobile and consoles or PCs for that part is if you profile the same thing twice, will you get the same results? On PC and consoles, answer is yes. On mobile, 95% of the times, answer is no. So here's a photo of what I do on my desk at work. It's a phone and a Peltier cooler and 3 cables connected to it. I was trying to find another photo. Before I had Peltier cooler, I was profiling on back of ice. So this is reality. These things are not actively cooled and they overheat. And depending on your AC setting, or have you hold the phone before profiling, or have you blown at it, or whatever, have you opened the window, you're even profiling the same thing will yield you different results. So please be mindful of that. Also, during profiling a very long sessions, be mindful, does the phone changes temperature during profiling? Do you have the headroom to do the profiling? A lot of times when we run profiling sessions internally, we see, okay, first 5 minutes, it's kind of cold-ish, it's doing good. And then after 5 minutes, it overheats and throttles down to like crazy low performance. A rule of thumb, just to think about, mobile phones in last few years and PCs of last few years have equal performance per core. They're literally the same, especially on Apple systems. The only difference is that mobiles can only perform as fast for first 10 seconds, and then they overheat. So if you snap a big cooler on the phone, it's quite good. On Android, we are working to get a performance mode, sustained performance mode on Android. It doesn't really exist. They have one right now, but it clocks down crazily. But if you work on iPhones, just use Xcode thermal throttle, or they have sustained performance mode. It just works. Just one checkbox in Xcode, and it solves most of your problems. Also be mindful that battery has limited power draw. So if you go full on GPU and you're just on battery, OS might tell you like, hey, this is not sustainable. So think about if you're plugged to a charger. If you're plugged to a PC, think about, can the USB port on PC output enough power for you? Some ports can, some don't. And unfortunately, it's not written on the port what will it do. So just be mindful that that might be a problem. And one thing that you might not expect is PSO cache. A lot of people are talking about PSO in terms of hitching, like, hey, I'm running my game, it hitches all the time because we are trying to cache PSOs here and there. Let me tell you, a tester captures a profile trace for Fortnite. We looked at it, and it's just first run on device. The only thing it does, it collects PSOs. So second trace on the same device will be completely different. So maybe consider just discarding first run, asking testers run everything twice or something. So this is a pitfall. Just be mindful of it. So profiling reproducibility is a huge problem on mobile. We're working on it. So it hopefully will be much better in the future, but right now you need to just think about this. Also, configuration pitfalls. I have a joke that Nanite on mobile is already here, because if you look on Fortnite in wireframe, it's all white. But because we have so many triangles. But Nanite is not here. You need to think about loads. The thing about loads, they're always misconfigured, especially if you have PC or console game that you're trying to port on mobile. Everything will be misconfigured. So internally, we were talking about, oh, we have 1.8 thousand triangles for a character. Is this good or bad? And people were like, this character, yeah, it's like half of the screen space. Maybe we can take it. 1.8 doesn't sound bad. And we were like, wait. This small 2 by 2 pixel is 1.8 thousand. because someone forgot to set the load correctly, and this was character flying 5 kilometers away. And the thing is, while playing the game, nothing will tell you. So you do need tools to look on wireframes and question everything. Like, hey, does that make sense? Does that make sense? And yeah, so loads are a big thing. You might even consider, hey, maybe I don't need load 0 for my character. Just put everything to load 1. Texture compression. Textures takes memory, and memory is, well, if you think everyone buys S25 like a new phone every year, maybe memory is not a big concern. But then you release a game and you realize they're trying to run it on like S10 or something, or S9, and you suddenly, hey, my game doesn't run in 4 gigabytes. So compressing textures using like hardware compression is almost a must on mobile. And there will be many cases where you assume a texture was compressed, but it's not. And the only thing we'll tell you is renderdoc or Xcode debugger. So please be mindful that textures are likely will not be compressed. So do interrogate them. Also, min-max MIP maps might not be set correctly. You might be rolling on MIP 0 everywhere. That might be also not good. And audio, if you just ignore it, audio will take a lot of your memory. So please be mindful that maybe you need to use compression on audio, enable streaming whenever you can, limit the streaming pools so you only stream in a second or two of audio. Scheduling pitfalls. This is something maybe unique to mobile, but especially on Android, you can assume your threads will be always on the wrong course because vendors think they know better than us. In this case, it's a screenshot of Fortnite replay, and we were investigating, hey, why suddenly everything runs on 16 frames per second? We looked at, it's a screenshot of Perfetto, which is Android profiler. We looked at this trace render thread, and there are 2 traces for render thread. I'm not sure how visible they are. But what essentially Perfetto told us, the render thread was scheduled on a big core, but then only running for half of the time. The top trace, it says it's either running or can be run, but it couldn't because something else was taking the core. And what we realized, we had like a low priority task that we couldn't care less how long it takes. But scheduler decided that it's suddenly a high priority task and it must be put on big core, preempting rendering thread and dropping our FPS. So internally, we decided that if you know about PC, usually you put affinity on every thread and you say, okay, I have this core for that core for that. On Android, it's possible, but very hard to do because there are so many different devices. So far, we just put low priority, we pin them, low priority threads, we pin them to low cores and let the scheduler decide what to do with big cores. But this is pretty much a reality, maybe not on daily basis, but on weekly basis. Think about it. Also, new phones come in with different core configurations, and that might also break this for you. Also, scalability pitfalls. If you make a game with Unreal on PC or console, you might think, okay, I only need like low, medium, high, and ultra or whatever quality levels. But there are so many Android devices. You might see an Android device with incredible GPU, but like 4 gigabytes of RAM. You might see Android device with 8 gigabytes of RAM or 12, but some shitty GPU for some reason. You might see a phone that have big battery, low battery. You might see, I think we hit almost every possible bug in GPU drivers on Android. So maybe Vulkan will not for you and you must use OpenGL, or other way around. Maybe OpenGL is broken on that particular device. be mindful that driver updates on mobile, at least on Android, are not a thing. So if you hit a driver bug, the phone is stuck with a driver. So you kind of need to work around it. Also, mobile phones have tendency to be released after you release your game, which is very convenient. So we release Fortnite and then, hey, Google Pixel 10 comes in. We need to do something. For live games, what you need to think about it, you might need some out of bounds hot fixing, because the turnaround to release a new version is just too slow, like at least a day. So what we have is called Android Configuration Rules System. It's a way to hot patch CVARs from a text file. So you can use that. There are some other third-party solutions for that. But for live games, I would strongly suggest you some way of hotfixing, like on CVAR level for Unreal. But that's pretty much for Pitfalls, mobile-specific ones. There are many other Pitfalls, but they're more generic to every platform. Like you might see blueprints or whatever else. Let's go directly to scalability. So now you've seen all the pitfalls. What do we do about it? Most of it would come into you editing some INI files. I know it's tedious, but this is what we have right now. You might mostly be familiar with scalability levels. So you write some sort of INI setting for low, for medium and high. We then added device profiles. So you can say, okay, for this particular device, I want this set of CVARs. This is great for consoles because there is only one PS5. Well, then they added Pro, but initially it was just one. For mobile phones, this doesn't work. I mean, theoretically, you could write a device profile for every device on the market, but that this is just not practical. There's like at least 2, 3, 4,000 you're gonna support. So we added device profile fragments. It's a part of scalability setting that you can set depending on some rules. And when this is not enough, if you do something like Fortnite, where you have one application and you make multiple games within it, we added scalability overrides in game feature plugins. So your sub game can do something else with scalability. For device profile fragments, we don't recommend a single device profile for mobile. Instead, we recommend you composing it from combination of profile fragments. Some example would be memory profile fragments. Let's say you target a 4 GB device, and then you just shrink all the streaming pool sizes to the applicable limit. Or if you have 12 GB device, you can say, okay, now you can stream whatever you want, just put it to the max. The same for GPU, you might limit the loads you have. In our case, we are often vertex bound, so we try to minimize the loads, but maybe in your case, you can do something else. You can also have different FPS profile fragment targets. Some mobile devices like to run at 120 or higher. So maybe you need to do some tweaks, lower some quality settings just to hit the FPS target. There is a small sample how to do a profile fragment for a specific GPU, but we are working to get you something representative of what we do on Fortnite. It looks like a bunch of regexes trying to match the GPU name. So it's coming, hopefully in 5.7, but maybe a bit later. And then if you know how to do scalability, what CVARs to edit, where do we get the information from? So Let's talk about a little bit about profiling. And gonna give you some tools what to use for different use cases. So the primary use case would be a bird's eye view. Because it's a live game and you're constantly making changes and constantly doing releases, you need to get a grasp of what's going on. And it's impractical for you to go and dig into Unreal Insights trace every build. Imagine you have like one build a day or maybe two builds a day, just too much data. So you need something for a bird's eye view. Then you need different tools for optimizing the game. Like, hey, the game logic takes too long. Think about that most of it can be done on PC. Mobile maybe not the most friendly platform to have a tight iteration loop on. We are trying to get you a better iteration loop, but it is what it is. And finally, maybe you have some platform specific thing. Maybe you have some rendering option that you only use for mobile, then you have no other choice than to actually profile on mobile. You can use mobile preview to see how it potentially will look, but mobile preview doesn't give you any option to actually understand the performance impact of it. And then I'm gonna mention a bit of future where we think profiling is going and maybe something to look for. So for bird's eye view, we have CSV profiler and low-level memory tracker. Don't ask me why there are two independent ones. And the acronym didn't age well. It's LLM. It was LLM before AI, so I'm sorry about that. It's very low overhead. And the important part, it can run in shipping builds. So you can enable all the optimizations you want and just have some idea what's going on with your game. Which is mostly not the case with sampling profilers because you will not get a good call stack or it will impact performance of your game too much. It's battle tested to run 20 plus minute replays. So, and you get maybe 5 megabyte file output. So it's very slim and easy to use. And it's great to just run on CI. So if you have some sort of device farm on CI that you can use, please try it out. It's a great tool, and we use it very extensively internally. So what about other use case? Let's say you want to optimize a game. Unreal Insights is a good option for that. In most cases, it has low overhead, but if you do like memory trace capture, it's somewhat heavy. This is the only profiler that knows a lot about Unreal Insights, so it will give you tons of counters. Probably it has more counters that I know of, so it's always you can look what might be a cause of your issues. But the primary difference from other profiles, it's instrumented. So it has a bunch of scopes in the code. And if you don't have a scope, you will not see what's going on. The sampling is coming. I'm pretty sure sampling on PC landed in 5.7. And we are working to get sampling on other platforms. But it has memory profiling. So if you want to know how many actors you have, how much memory they take, what's your streaming pool sizes and so on, this is the tool to go to see it. Also, something that we shipped for mobile, I'm not sure if you know, but on computers there is swap. So if you run out of memory, your extra memory goes to swap, which is usually a file on disk. But not on mobile. On mobile, they decided they don't want to write too much to NAND, so it's a compressed file in memory. So essentially, if you run out of memory, they just compress it. We have some extra tools for swap analysis on iOS. They're coming for Android, but right now on iOS, you can see if you allocated something in the beginning of the game session and then haven't touched it for 20 minutes, you will be able to track down such memory. And on Fortnite, with that tool, we tracked around 100 megs. There was someone allocating a big buffer and not touching it for 20 minutes. So we just like, hey, free this buffer before going to the game session. And one thing that you might consider, usually on consoles or PC, you might run, this is command line arguments for the client. You might say, hey, trace, default is like catch all, trace all the text and so on, and memory is just trace the memory. But you trace to host, it's usually just automatically connected for you if you run Unreal Insights. Trace to host will go via network, and this is usually fine if you just have low bandwidth capture. But if you want to capture memory, for example, on mobile, what might happen that there is so much data coming in real time to Unreal Inside server that it overflows Wi-Fi connection. And then inside your game, there's a tracing buffer, and that overflows, and then your game just stutters because it tries to flash it, and it will block on flash. So please consider that you might need USB 3 connection for that. And if you don't have that, maybe you can replace trace host with trace to file. So that would be offline trace where you trace to file and then download it from device and look in insights. Just something to keep in mind. Another great option that probably a lot of you in the room used is Superluminal Profiler, where it just happened to be loved by a lot of people in the industry. So it's a great go-to tool where you don't know what's happening, just throw it on your, well, in this case it would be PC or console version, and look, is my game logic doing something silly, or is it something during loading times or whatever? Fortunately, they don't have any mobile support. Maybe it's coming in the future, I don't know. But this is a good tool if you haven't used it before, just to see what's going on. Then some tools to work with GPU. Because there is no non-night on mobile, at least yet, you kind of need to look on wireframes. This is what you have to do. RenderDoc is one of them. It works on Android. You might have intermittent success. You might get special version of RenderDoc just for your GPU or your device. But it does work. It's what we use internally for Android. It might be a bit confused with Unreal because we create OpenGL context first to see if we can run Vulkan. So if you try to capture, it will try to capture the GL as context first. So you might need to press capture a few times to trigger Vulkan capture. Xcode Metal Debugger. 5 years ago, Xcode didn't have great tools, but right now they're amazing. Like if you have possibility to use it, try a metal capture in Xcode, and it will give you more than enough information. So what to do with them? Look at wireframes. If it's plain white, think about like, hey, maybe we need to do something about lots. If it's not white, maybe you're good to go. Look at the textures, just sort them by size and like, hey, can we compress you? Can we use different MIP? Can we do something about it? I think on UFN we've once failed where customer uploaded a texture and it failed to compress on Cook. And suddenly a simple 3D texture suddenly was 256 megabytes on the device, simply because it failed to compress. So compression is a big thing. And then literally look at all the buffers, sort them by size and question them. Do you need to be this big? Can I make you smaller? I know it's a bit harder to do it unless you literally Unreal programmer on mobile team. But that could be a good start if you identify, hey, something doesn't make sense, and report to us. This is so much better than not understanding what is the problem on your project. Xcode instruments, as I mentioned, great GPU tools. You can go nuts on that. It's the only mobile platform right now that has sustained performance mode. And we tried it and it works. So if you ship on iOS, try it. It will make your profile capture so much more consistent. But unfortunately, it's only for Apple devices, which means usually it means you need Mac in connection to buying a phone. Perfetto, it's a go-to profiler for Android. We have so many complaints about it, but it's great for CPU scheduling. So if you're confused why my thread is at the wrong place, this is a tool that will answer why. Because it will tell you if it's waiting for something or someone else preempted you or whatever else. And you can use this to put, if you need to do affinity settings on threads on Android, this is a great tool to do it. It also will report clocks for you. It's a bit a limited use case if you can use clocks to do something meaningful. But what we noticed that GPUs on mobile are very bursty. CPUs are bursty to begin with, but GPUs are crazy bursty. Like within, let's say your game runs at 30 FPS, within a single frame, GPU might change frequency like 5 times. So you might want to play with tricks like, hey, do I want to merge everything in one pass? Do I want to split? Right now we are doing like multi-pass to leverage better utilization. But if you can do something about clocks, that could be, you can win some tens of milliseconds here and there. And finally, the vendor tools. So there is Snapdragon Profiler for Qualcomm chips and ARM Streamline for Mali GPUs. Well, if you use them, they look like 500 graphs, and then you think about like, what am I looking at? There's so much data that there's more data that anyone can practically do something about on the game level. But why am I mentioning this? They can be good to figure out if you're bound on something. Like, are you bound on vertices? Are you bound on memory? Maybe your L2 cache on GPU is empty or is full, like this kind of level things. Also, that's the only tools that will tell you instruction counts. So one thing to be mindful of, because GPU changes frequency so much, like 5 times a frame, you can look at instruction counts and see, because they will be the same regardless of the frequency. So that's one way to think about shader performance. You just look at instruction counts. But this is not something we use day to day. It's only when, hey, we have this phone, we need to optimize for it. And finally, the future of profiling. So we have this great Android automated perf test framework. Right now, the public version can only run one. It can only generate a report once in Hort. Internally, we have something that collects them into a unified UI, so you can look at different reports between different versions and how they changed. We are working to get it into Hort, so you will have like a turnkey solution to work on it. Something that I can only mention, I cannot give you any details, but Samsung and Google are working on a new GPU profiler. They announced it at some conference recently. I'm not sure if there are any public information on it yet, but it's coming. GFX Reconstruct is working to be a replacement-ish of renderdoc. It works today, but what's coming is they're trying to make a cross-device replace. So you will be able to capture a Vulkan replay on a device, then throw the device out and run this replay on your PC. hopefully it works. It's a lot of magic behind it. But if that works, it will be an amazing tool to debug Vulkan issues on mobile. The sampling, as I mentioned, in Insights, PC version should be available in 5.7, but it will come in to more platforms in the future. So keep an eye on that. And most of this talk, or a good chunk of it, was about thermals and so on. We are working with Google to get you better reproducibility on Android. iOS seem to be half solved at this point, but this will come in the future. And better memory visibility. Right now, there is almost no visibility on Android if your memory is in swap or not. And the amount of memory you can use kind of depends where your memory is. So we are working to get you a more transparent visualization where your memory is and what to do about it. It's a bit better on iOS, but it's not perfect. Like, we managed to get Unreal allocations in Xcode instruments. So you have a bit more understanding if my Unreal allocation is in swap or not. There is also swap analysis in Unreal Insights. And something I want to mention that doesn't really exist on any other platform, but Android landed in-field profiling recently. Google landed it in Android. This is a very obscure feature, so I had to put QR code just so you're able to find it. What it allows you to do is to ask devices that run live game, like release game, to, hey, please capture a perfector trace on a device without telling the user. So you will then be able to take this perfector trace from device and upload to your cloud or whatever solution you might figure out. And this will allow you to understand how my game is performing in live, and on much deeper level than just usual metrics from solutions that we have today. So this is what's coming maybe in the next few years. Internally, we are very excited about it. But right now, this is what we have. And thank you for today's talk. I hope it was not very bothersome. And I'm ready for any questions if there are any.